Okay, let's look now at how to book the angle readings in the booking form in the field book. Okay, we are at 2 now, and we're facing 1 back station and station 3, so forward station, given the horizontal circle reading for the back station and the forward station in the top figure. So if you look at the table underneath that figure, each line represents each point. So the first line, that one there, represents observation that 4.1, and the number in the circle, number 2, is where you are, where the instrument is, and the third line is meant for the values for the forward station. Now, we're going to start with face left. Face left to the back stations 2774530. So that's why exactly what we do now. We'll write that number there. And then followed by face left for the forward station. So that goes here. 69 1520. Okay. Then we're going to change face. We're going to read that. We're going to read the forward station that I put there in that line, in that row for station 3. And finally, when I close the job with the final reading on face right, 97 45 50. Okay, so the order of observation would be number 1, number 2, number 3, and number 4. So which means we're going to start with left, left, left. Then we're going to change face, right, right. So it's back, forward, forward, back. So that is one complete round. Okay. Now, how do we get the mean? Okay, let's erase this markers here, so that's a bit more clearer. Now, look at the column for mean here. Right, look at the degree 277 and look at the degree on face right. So if you see, it's exactly 180, which means that we're okay, no gross error in there. So we're going to write the degree first, that number first. Okay, now to get the mean, 45 30 45 00, so in between will be 45 15. Okay, similarly to that, okay, for the forward station, 69 on left, 249 on right, so that's good. There's 180 degree difference. So we just write down 69, so that's the number is valid. Then we have 1520 and 1600. So in between those two numbers will be 1540. So that's how you calculate the mean, as I explained in the previous slides. Now, to get the angle here, is always forward minus back. So in this case, 69 minus 277. Okay, that number minus that number will give you a negative value. So you simply add 360. Okay, simply add 360 and you get that angle that we require. So it's always forward minus back. Okay, now let's move on to distance measurements now. Okay, distance measurement basically refers to the horizontal distance that we want. Okay, when we do the calculations, we need the bearing, we need the distance. So distance that we are talking about is the horizontal distance, so between the traverse leg, okay, or the traverse stations. Right. Now that's just an old picture that I got from the internet, just to show how things were done way back, in the last century, in 1916. Okay, it's a what they call it, a party. It's a survey party. It was comprised of a few men. In this picture, we could see 6 people were involved, measuring a line, and they were carrying a steel tape. Okay, so it's quite a feat actually. Okay, it's not something which can be easily done. Okay, it's a teamwork. So anyway, that's how it was. Okay, way back in the early 1900s. So now we got to be thankful to the technology, to electronics. Okay, equipments are getting better, getting smaller, and life is a bit easier now. So when we measure distances now, we make use of the technology, we make use of EDM, okay, as I mentioned earlier, electronic distance measurement, which allows distance to be measured quite accurately. Okay, we have early devices, okay, as shown earlier, they mount on the theodolite, but these days, okay, most people now are using a total station, okay, simply because it's quite reachable in the sense that it's not that very expensive, and it can provide you with high accuracy. Right, next, how does it work? How does an EDM work? Okay, I've got a little picture here, just to show how things, or how do we go measuring distance using an EDM or total station. Okay, it sends, when you use this, when you use a total station, you need the instrument on one end, on one point, and you need a prism on the other point, okay, on your forward station or your back station. So what it does, what the instrument will do is it will send electromagnetic wave to the prism, and that wave will be reflected to the total station. So using onboard software, by analyzing the wave, okay, the EDM can actually come up with the distance, okay, based on the wavelength and based on what we call the phase difference, okay, between the wavelength. I'm not going to go into detail, okay, but that's basically how it is. That's how it works. So based on those numbers, you are now able, or it is now able, for the instrument to calculate what the horizontal distance is based on the vertical angle that is observed, okay, theta in that case. Alright, so it is quite straightforward now. Just merely pressing a button and you'll get simultaneously your horizontal distance as well as your slope distance. Alright, okay, now that's how distance is obtained, yeah, as easy as pressing a button now. How about bearings? Okay, we talk about observing angles, okay. So what we observe in the fields are angles, but when we do our calculations, we need bearings, okay. So we have to convert those angles into bearing, okay, because the coordinates that we want to calculate, the coordinates calculation or computations, make use of bearings rather than angles. And when I say bearing, I refer to the whole circle bearing, okay, rather than the quadrant method of writing down angles. Okay. Let's look at that one example there. Supposing that we are at Y and point X or station X is our back station and station Z is our forward station, and we were given the bearing Y to X, okay, from north, that value there, from Y to X. And in the field, we'll be observing that angle, the left-hand angle. Okay, we call that the left-hand angle. Okay, so the angle that you observe are called left-hand angle. And to calculate the bearing for that line, okay, I'm going to change color now. Okay, which is that angle, probably use green, which is that angle there. That's the bearing. Okay, so the bearing will be the angle, the green, the one that I've written in green, from north. Okay, so how do we calculate that? Okay, it's quite straightforward. Okay, because to get it done, to get the calculation done. Okay, now the forward bearing simply given is given by the back bearing, which is that value there. You're going to add with to that back bearing the left-hand angle. So it's back bearing plus left-hand angle. Okay. So forward bearing. So forward bearing is back bearing plus left-hand angle. Okay. Forward bearing in this case is Y to Z. Back bearing in this case is Y to X, and the left-hand angle is basically the clockwise angle that we measure at point Y. So if you have summed the values and you end up with a value greater than 360, you simply take away 360 from that number to get you the actual bearing. Okay, let's do some two examples. Okay, I've got two examples in there. Okay, I'm going to give you a minute probably, just think about it, and I'll come back in a minute. Okay then, the first question says, if the bearing of a traversal like 2 is given as 116, 45, 13, calculate the bearing 322. Okay, so now you're given 223, now you're interested in 322, meaning that if I'm going to call that as a forward bearing, okay, forward bearing. So that will automatically be the back bearing. Okay, so forward and back, the value or the number should differ by 180 degrees. Okay, plus minus depending what the numbers are. So if you were given 116, so your bearing 322 should be 180 degrees difference to that. So it should be 296. Okay, 45, 33. Right, let's look at the second one here. It says it has a back bearing of 276 1143. So that's 425, and you are required to calculate 524. So you need a reverse to that, a difference of 180. Since one is more than 180, so in this case we take away 180. Okay, which means that it's 96 1143. Okay, so that's how we calculate bearings or forward bearings given a back bearing, and then vice versa. Okay, let's look at this one now. This is a bit different. You're given, in this case, point A, B, and C are 3 consecutive travel stations. If the left-hand angle observed at station B is 326, 10, 20, and the back bearing, B to A, is 155, 55, 32. Calculate the forward bearing. You're given a back bearing. You're given a left-hand angle. Okay, so we know that forward bearing, okay, forward bearing is always equals to back bearing plus left hand angle. So in this case it's 326 1020 plus 155 55 32. Okay, so if you add those two numbers, okay, you will have 52. Then you have 65, which means 05. So then you have 327 or 326 plus 155, which is 482. Okay, 482. But there's no 482 obviously. So you take away 360 from there. So you'll have 122 05 52. Okay, you add those two numbers. If it's more than 360, you just take away 360. Now the second question says calculate the forward bearing for the same line if bearing A to B is given instead of B to A. So initially we were given B to A. Okay, now let's say you're given A to B rather than B to A. So that means you need to get the reverse bearing for that. Okay, so in this case you take away 180. So it becomes 170, where should I write it up here? 178, 11, 28. Okay, now the answer would be that back bearing, which is 178, 11, 28. You're going to add the left hand angle, which is 326, 10, 1020. So that gives us a forward bearing of 48. 10 plus 11 is 21. Then we have 178 plus 326. So that gives us 504, but we don't want 504. So we're going to take away 360. So we got 504. We'll take away 360 from there. So your answer would be 144. Okay? So that's how you go about calculating forward and the bearing based on the left hand angle and the back bearing given.
انضم معنا الآن واشترك بالقناة ليصلك كل جديد. YSAG، معا نحو مستقبل مشرق.